Welcome back to your remote learning experience. Today's lesson is going to be a review of the worksheet that I gave you guys yesterday to work on, which was to calculate formula mass and molar mass. Okay? So the way that this is going to work is I'm going to give you another review sheet for today that you can do on your own, and it's going to be a practice sheet because tomorrow's Wednesday. Thursday, you guys are going to be having a brief quiz on formula mass and molar mass. This is a relatively straightforward concept, but if you have questions or are confused in any way, please email me. I'm also, hopefully by now, have sent out Zoom time, so if you would like to Zoom in and ask me questions about this topic or anything really, we can absolutely do that as well. So today I'm just going to go over this sheet, which had just 4 problems on it. I'm also going to post the answer sheet. So if you just want to look at the answer sheet and call it a day, that's fine. But if you want me to explain it to you and babble at you, then this is for you. Okay? So the instructions were to calculate the formula mass and molar mass for each of the following 4 compounds. If the name is given, write the correct formula before calculating the formula mass and molar masses. To receive credit, work must be shown as it was demonstrated to you during the lesson. This is a 20-point classwork assignment. Email me with questions. All right, so let's go over number 1, which is barium phosphide, it looks like. Okay, so actually need to pull out a periodic table very quick. Periodic table, here we go. So I'm going to have this up just as a reference. And so if you guys want to use this one, all I did was type in dynamic periodic table into Google. It's pretty interesting and pretty interactive. So if you'd like to use this one, I highly recommend it. All right, back to the problem. All right, so I have barium phosphide. Okay, so get out my handy dandy pen thing. All right. So first, I need to make sure I count how many atoms are in this whole compound, okay? And it looks like I have 3 atoms of barium, just by looking at that 3 subscript. And then I'm going to put some parentheses right here. And that's where the atomic mass or the molar mass is going to go. Remember, the atomic mass and the molar mass are the exact same thing. Exact same number, they just have different units, okay? And then I'm going to add it to 2, because I have 2 phosphorus atoms, times whatever mass we have there, okay? Oops, didn't mean to do that. Oh my goodness. There we go. Okay, so looking at the periodic table, I'm going to go to barium, which is down here, 56, and its mass is 137.33. So I'm going to put that right here. Hopefully this thing will let me do my thing. 137 point, to move this. See, this is just not doing what I want it to do. Point 3. Oh God, I apologize for this. 3. All right. Yes, 137.33. Maybe we can do that a little bit better. Maybe I should do a text box. Why didn't you guys tell me I could have done that? All right, now phosphorus. This is just incorrect. You might just want to look at the review sheet because I'm struggling. There we go. 137.33. Okay, and right here, phosphorus, its mass is 30.974. I'm just going to round that to 30.97. Let's keep it to 2 decimal places. All right, so if I do the math real quick, 137.33 times 3 is that is 411.99, and that's going to be plus 2 times 30.97, 61.94. And if I add those together, dear Lord, no, I get 473.93. 73.93. Okay? So remember, this unit is going to be, there's two ways that you can go about this right here. So it's either going to be grams, like this, or it's going to be in AMU, like that. Okay? So that would be my final answer, is 473.93 grams per mole, or 473.93 AMU. Hopefully that makes sense. I think I'm going to use the text tool from now on, because this other one is a nightmare. All right, this is actually going to be your answer key that I'm going to post online, which has been done a lot better than what I'm doing right now. All right, number 2. So bear with me. First, I'm going to count my atoms. It looks like I have this 2 right here is going to distribute right here to that nitrogen, and it's going to distribute to that hydrogen, okay? So actually, I'm going to multiply that subscript by the subscript inside. So 2 times 1 is 2, so I have 2 nitrogen. Why did it do that? Maybe it's because I need this one. Yes, that's why. Okay? Then I'm going to add it to 8 hydrogen. This 2 right here is going to multiply that by 4, and that's 8. All right, going to add that to my sulfate molecule right here. So I have 1 sulfur atom, so just 1 multiplied by that mass of sulfur, and then 4 oxygen. Just like that. Okay, so let me get a text box going here. All right, so my mass for nitrogen, if I go back to my periodic table, is 14.007. I'm going to round that to 14.01. All right, my mass for hydrogen is 1.008. I'm going to round that up to 1.01. Oops. All right, 1 sulfur atom, that has a mass of 32.06. And then 4 oxygen atoms, that is 15.99. I'm going to round up to 16.00. Okay? So all I need to do now is do some quick math. All right? So if I take, I'm actually going to do this online so you can see it instead of doing it on my phone. So I'm going to have 2 times 14.01 plus 8 times 1.01. Hopefully my order of operations are correct. Looks like it. Plus 32.06. And then plus 4 times 16. Okay, so my final answer should be 132.16, and that's pretty dang close, all right? So my final answer would be either 132.16, I believe we found, and that could be in AMU, or I should say and, so that's my formula mass right here, and then my molar mass is 132.16 grams per mole. Okay? Remember that mole, in every single mole, we have 6.022 times 10 to the 23rd particles. Okay? So that means in every mole of ammonium sulfate, there are 132.6 grams. All right? So these next two, I didn't give you the formula, so we have to do that on our own, okay? So first, I'm going to write out the formula. I'm going to write out the symbol. What on earth is that? For sodium. Then chlorate. If you don't have your periodic table, good Google search will do you some good. Or, I mean, your polyatomic ion sheet. So the formula for chlorate is ClO3 with a -1 charge. Okay? -1 and the +1 on nitrogen are balanced. So there's no need to alter this formula at all. That would be it. Okay? So I have 1 sodium atom. I'm going to add that to 1 chlorine atom. And then 3 oxygen atoms. Okay? And that would give me my answer. So I'm going to go back to the periodic table real quick. Sodium has a mass of 22.99. So I'm going to put that down. Right down here. 22.99. Quick copy of that. All right. Go back to the periodic table. Look at chlorine. 35.45 is its mass. 35.45. And then lastly, we have oxygen. Okay, oxygen 15.99, but I've been rounding to 16. Whoops. All right, so quick math calculator. 22.99 plus 35.45 equals, and then I'm gonna add 3 times 16. Perfect. So my final answer should be 106.44 AMU and 106.44 grams per mole, just like that. Okay, so let's see if we got this correct. Pretty dang close. Okay, so let's go to the very last problem, dinitrogen tetroxide, okay? This is a very nice compound because it tells you how many atoms that you're going to need. Remember, covalent compounds, we name them using prefixes, so this is very helpful. You don't have to do any balancing of the charges. You can kind of just go at it right away, right? So nitrogen, 2 nitrogens, so that's dinitrogen. Tetroxide, okay? So tetra is a prefix that means 4. So this would be my formula for this, okay? So I have 2 nitrogen atoms right there. I'm going to put a 2, then wait to put in its molar mass, or its mass. Then 4 oxygen, just like this. Go back to the periodic table. I'm looking for nitrogen. Nitrogen, 14.007. I'm going to round that up to 14.01, just so I can keep 2 decimal places. All right, and then we've been dealing with oxygen a lot. Its mass is 16. So what's really nice about these is once you've done enough problems of these, you actually kind of start to remember some of these numbers. So obviously it's okay if you don't remember the numbers, but the more you use them, the more you'll start to know, hey, carbon is 12.011. Maybe you'll get there. I would hope so. All right, so I'm going to add these together, do some quick math. So I'm going to take 2 times 14.01 and then add that to 4 times 16. I get 92, 92.02 AMU, or 92.02 grams per mole. Whoops. Just going to do a quick check of that, make sure it's correct. Perfect. All right, so those are the answers step by step to this practice sheet. I'm going to upload this, but in a more thorough manner that looks like this, so hopefully you can understand it. You don't have to watch this video if you don't find it useful, but if you want to hear me babble on step by step on how to do this, you can absolutely do that. Okay, so that's going to be it for today. Do the practice sheet that I give you for tonight, and you are going to have a quiz on Thursday. So have a fantastic rest of your day.